Now let's look at ocean temperature. The Earth is 2/3 water, which stores and releases a lot of heat, and that has a big impact on climate. That impact is mostly cyclical. This is the Atlantic multidecadal oscillation, the MDO. As you can see, the temperature of the sea surface rises and falls by about 0.2 of a degree every 60 years or so. That's quite a lot of energy. This has been going on for millions of years, and all the creatures in the sea are used to it. These ocean cycles have a big impact on our climate. Matt Makins, a meteorologist in Colorado, shows 3 ocean temperature cycles that play some role in determining our climate. This one is the Pacific Decadal Oscillation, the PDO, which is a change in atmospheric temperatures. I'm going to put my adjusted graph of US temperature behind it just to see if we can learn anything. I'm not using any values for temperature here, just looking for any kind of correlation. Now this is the El Niño Southern Oscillation, the ENSO. It's responsible for the El Niño and La Niña variations in temperature every 3 to 11 years. Here's the Atlantic Oscillation, the AMO. It looks like this one might have some influence on US air temperatures. Now, I got the idea from Matt to combine all 3 of these ocean cycles just for fun, and here's the result. This isn't really science, this is just a hunch, but a hunch is something you can test. Some years, the 3 cycles more or less cancel each other out, while other years they coincide and help create extreme weather events. Well, that's true, but I wouldn't expect full prediction power here, and the West Coast is going to be different from the East. Yet there is some degree of correlation after 1960. There are a lot of variables and a lot of uncertainties in these variables. The most important takeaway is that climate is noisy, complex, poorly understood, and impossible to model accurately. Yet a lot of people believe that temperature is being driven by carbon dioxide, which you can see here in pink. That's because NASA and the United Nations use models driven by CO2 to create their projections of future warming. Richard Lindzen of MIT, who helped me with my research, wrote, "Future generations will wonder in bemused amazement that the early 21st century's developed world went into hysterical panic over a globally average temperature increase of a few tenths of a degree, and on the basis of gross exaggerations of highly uncertain computer projections combined into implausible chains of inference, proceeded to contemplate a rollback of the industrial age." Next, let's look at ocean acidification.